Hi everybody, so my first section for this lab 1, we're just going to run through the pre-lab real quick. So we see that the statement we should be getting for the output for the 2-to-1 multiplexer is A S naught or B S. I drew the circuit here. Here's my truth table. You can see there's actually 4 possibilities that set it high. However, you can simplify this down. You see some of them like for the A S naught, the B is irrelevant, and then for BS, the A, whether it's high or low, is also kind of irrelevant. So you can simplify it down into this. The next step that we see is for doing this, these 2 outputs in Circuit Lab, getting the 5 volts and then the 61.27 millivolts on the voltmeter. We see here I have my circuits, and then just running that again. Yeah, you can see there's the voltages. And then part 3 is the 2-to-1 multiplexer. So we see right now I have A and S as both 0 volts. If I were to sit here and change A to now 5 and now go back and run it, you see that the output is now 5 volts. If I were to, let's say, make B 0 and I don't know, make S high, the selector high, and now we run it again, you see that's 0 because that's not one of the options to make the Z high in the truth table. So then part 4 is just kind of making this in Tinkercad. We have our NOT chip, our AND chip, and our OR chip. We see the 330 ohm resistor then to the LED, and that's grounded. Red is power, black's ground. We see the selector green, the A input yellow, B is blue. So if we run this right now, let's see, we have the selector is off, we have A is high, so that should cause the LED to go on. We see the LED goes on. Now if we were to say that B is low, or sorry, A is low, and make the selector high, B is also high, so this should also still have the LED being on, and the LED is on. Now if we were to turn B off, now only the selector is high, so it should be off. And as you see, the LED is off. The last part right here, we just have the 4-to-1 multiplexer being made out of 2-to-1s, and you can see there's the system right there. Here's the logic that gets you each of the different outputs. Okay guys, now I have my circuit wired up. You can see I have my red is in power, black is in ground. Same thing here. I have my selector. I have A is yellow, B is blue, and then Z, I just labeled that as the output, which we're running through the resistor, the 330 ohm resistor, through the LED, which is then grounded. We have the NOT gate, we have the AND gates here, we have the OR gate here in this chip. And so we can see right now that the LED is off. We have the selector set in ground, A ground, B ground. If we were to move A to now high, LED turns on. If we move the selector to high, it turns off. If we move B to high, then it's on as well. Okay, and then here's the final part of this lab. We see A is in pin 4, B is pin 8, which you can see here. If we have the selector in ground, it blinks fast. If we move the selector now to high, it blinks slower.